Okay, so next I'd like to talk about kinetic energy. This is basically how the work changes your speed. So, um, kinetic energy is the amount of work required to stop an object. Another way to say that is it's the amount of energy, but we're still sort of defining energy, um, in the motion of the object. So uh, basically, what we're saying here is the work is equal to um, kf minus ki, or the work done in a process is the loss of the kinetic energy. Okay, so the work done in a process is that loss of kinetic energy. But another way to say that is this kinetic energy is equal to W to stop, the amount of work to stop. So if we were stopping, then the final would be zero. There'd be no energy left in the object, in the motion of the object. And so Ki would be basically equal to work, right? So I guess it's minus stop. It's again important to realize now we're working with another um, word, energy, that is not exactly what you use it for in real life. So in real life, energy, you might think about music that's got a high energy. You might have a person that has a high energy who gets a lot of things done. Previously, when we talked about work, work is a mathematical analogy to what we think of as work, right? But they're not exactly the same, right? It's just an analogy, right? The mathematical definition is similar to what we think of as work, but not exactly, right? Here we're going the other way. Energy was an idea created by physicists in the 19th century, and then it leaked out into the rest of the world and it turned into all sorts of weird things, like spiritual energy or something like that. So um, we have here a similar uh, change. We're thinking about things now in terms of technical terms. So work is a lot like labor, which uses a lot of energy, um, which is a lot like motion. So that's where these things all come together. But you have to think about these things now very, very specifically. You have to be very, very careful that you're not bringing in too much of your regular language into these technical definitions because that will screw you up a little bit. So we're going to sort of fix that here. Then we need our definition of kinetic energy. That's going to be 1/2 the mass times the square of the velocity. So the faster you're going, the more energy you have, and the faster you're going, it's much more. So if this is your kinetic energy and this is your velocity, then if you're not moving, you have zero kinetic energy. And if you're moving really, really fast, it goes up faster and faster and faster. It's not a straight line. So this is a nonlinear sort of thing here. So the faster you go, the more energy you have. So basically the definition we have here is that if you've got your boat and you're going really fast with some velocity v, right? Let's put you there. And you turn off your motor and you come to a stop. Let's just say you pull it out and put your hands behind your back and do that. And you coast to a stop. The amount of work done is the change in that kinetic energy from way up here down to here. Right? So you can see you're going to require more and more energy more and more work to get more and more energy to go faster and faster. And we'll talk a little bit more about this in class, hopefully, and use an example of, say, a shipping crate. So I'll do one example for this, then we'll talk about temperature, and then I'll see you in class. All right, bye now.